Hi, my name is Harold Schuch. I'm a lecturer at the Department of Civil Engineering at the University of Colorado, Denver, and welcome to this module on three-dimensional traversing. Let's say we have a sample project. Here we see in green the outline of a parcel, and in blue a building that has to be positioned within that parcel. And so we have to make sure that this positioning takes place three-dimensionally. First, it has to fit the polygon of the parcel outline as designed. And second, it has to be level and at the right elevation. So that means that three-dimensional traversing, as we are going to talk about, is a three-dimensional effort. It involves horizontal positioning and elevations. Let's say for this purpose, a surveyor has given position of one of the corners, in this case, for example, this one, and has measured this parcel. And what are the data that the surveyor will provide? And what does he need to do to calculate a result? What the surveyor measured is the distances of these traverse legs. Then he measures horizontal angles, one angle at each corner. And then he measures vertical angles that are going to be used for the transfer of elevations from one point to another. So the horizontal portion of a traverse would be this. However, this is not what is being measured. What is being measured is slope distances. Let's say once the instrument is set up here and this is measured, all distances are really slope distances, and that cannot be avoided. That means that if I want to calculate a horizontal solution for this, I would have to first calculate horizontal distances. So I calculate these horizontal distances as follows. I would have the instrument set up at one point. I would have a prism set up on a second point, and I measure a slope distance. In addition to that, I measure a vertical angle. From the slope distance and this vertical angle, I can calculate the horizontal distance and the vertical distance. So I can use this horizontal distance, or HD, for the purposes of my horizontal solution for the traverse. Something that should never be overlooked is something that we need to add, and that is that it is very important that every time you have an instrument set up, that you measure the height of instrument with a tape. At the same time, you measure the height of the reflector with a tape, because we're going to use that. You might not be able to calculate everything if you forget to make that measurement. So how do you calculate the horizontal distance? That is simply the slope distance times the cosine of this vertical angle. And the vertical distance is simply the slope distance times the sine of the vertical angle. If I now want to transfer the elevation of point A to point B, to which I measured my slope distance and my vertical angle, for which I have calculated my horizontal distance and my vertical distance, I would have to simply do this. I take the elevation of point A, I add my height of instrument, then I add my vertical distance, and I subtract my height of reflector. And that is reflected in this formula. And I can use this information to calculate a difference in elevation between point A and point B. So now I transfer the elevation from point A. Let's say that the surveyor gave me 3 coordinates for this point, x, y, and z, where z is the elevation. I can calculate the elevation for B, and then I can, from B, I calculate the elevation of C, and then the elevation of D, and finally back to point A. So after calculating the transfer of elevation along each traverse leg and returning to point A, at this point we will have the given elevation of A as the surveyor provided it, and the elevation coming back along the traverse to this point. The second elevation will reflect any errors that were made during that process. And we can compare the given elevation with the calculated elevation. If there's a difference, we will call that a vertical misclosure. This vertical misclosure should be checked. If it's too large, according to the purposes of a specific project, then the measurements of the traverse have to be repeated, have to be done again. If the misclosure is too large to be acceptable, let's say greater than 2/100 of a foot per traverse leg, then the traverse again has to be remeasured. If it is negligible, we don't have to do anything. We can ignore the difference and just work with the calculations we have. If it's small and still too large to be negligible, we have to adjust this traverse. And the idea is that if we need to adjust the traverse, we split the difference in the elevations by the number of legs and apply the same vertical correction to each leg. So we have to recalculate the elevations. Now, from the horizontal perspective, we have to calculate coordinates. And let's say we have the coordinates for A known. So we are going to work around the traverse and calculate the coordinates X and Y of B, C, D, and back to A. The same kind of an idea. We do a complete loop around the traverse. But for that, we first have to talk about directions. As you can see here, we have two ways of giving the direction of this leg AB. And the first way is called a bearing. This here says that this leg points more towards north than towards south, and it points more towards the west than towards the east. That's what these things mean. In addition to that, we have an angle. This here says that the angle was measured from the north. So from north, this is the angle. And if this instead would say south, then we would measure the angle from the south cardinal direction in this way. So, and here it says west. That means we're going left of north. If we would say east, then the angle would go like this. So that's the quick story about bearings. There's another way of showing the direction, which is called azimuth. The azimuth of this line is measured from north. It's always clockwise and ranges from 0 to 360. This is always measured from north. So using the azimuth for calculations has several benefits. And that is why surveyors prefer azimuths for calculations. So let's see what we can do with azimuths and bearings. There is something that is called departure or latitude. Departure is the difference in x between 2 points on a line. And latitude is the difference in y between 2 points in the line. So this would be delta northing and delta easting, or delta x and delta y. These two quantities depend on the horizontal distance of the leg and its direction. In this case, this leg goes from A to B. It does not go from B to A for this purpose. Remember that the azimuth of this line going this way is this azimuth here minus 180 degrees. So the azimuth can change drastically when we talk about direction. I go back one slide and I talk about the bearing of this line going from B to A, then this would change to south 30 degrees, 15 minutes, 45 seconds east. So that would be the direction of this line from B to A instead. And so we can calculate latitude and departure for each leg. We can do that for every leg. Now, one thing to watch though is that if we use bearings, then we use the cosine for this part and the sine for this part, as shown here. If we use the azimuth, then these two get switched. We use sine for this part and cosine for this part. So here we have the coordinates of point A, we want to calculate the coordinates of point B. We simply take easting of A plus the departure gives us the easting of B, or the x of B. We take the northing of A plus the latitude, that gives us the northing of B. And obviously we can repeat that all around the traverse. Here you'd say, wait a minute, this is a negative value for delta E. That is correct. If you use the azimuth, for instance, of the angle that was given before, you will see that a negative sign comes out of the trig function, and that automatically makes it a negative value. So it is then the calculation itself, the trigonometry, that gives you the proper sign for your geometry. That is another reason why surveyors prefer azimuths. That is not the case for bearings. So now we calculate horizontal coordinates along the traverse. If we do this along each leg and come back to our starting point, we may end up with a difference. If this difference is negligible, you can ignore it. If this difference is large, you will have to remeasure the traverse. If this difference is relatively small, but you cannot ignore it, then you have to adjust the traverse. And that is done in most cases. This difference, you will have a difference in X and a difference in Y. That's called a misclosure, and you can adjust for that by watching the module called the three-dimensional traverse adjustment. I hope you load it down and watch it. I thank you very much for your attention, and I hope to see you in the next module. Bye-bye.